Have you ever helped a friend or family member deal with a flat tire on the side of a road, gone to lift the boot floor expecting to find a wheel, and found instead a small aerosol can and a portable compressor no bigger than a lunchbox? No tire, no jack, no wheel brace, just a tube of foam sealant and a set of instructions written in 8 languages, in print too small to read without moving closer to a streetlight. The feeling is disorienting in a specific way. You know what should be there. You've seen it in every car you've ever owned or borrowed or watched someone change a tire on. The spare wheel is one of the oldest and most universal features of motoring. And yet here, in a car that was manufactured to extremely precise engineering standards by one of the world's largest industrial corporations, it's simply gone. Across the major car-producing nations, roughly a third of all new vehicles now leave the factory without a full spare tire. In some vehicle segments, particularly in smaller hatchbacks and in electric vehicles, that proportion is considerably higher. Hundreds of millions of drivers are currently on the road in cars that cannot be fully repaired at the roadside after a puncture, and a significant number of them have no idea this is the case until the moment they need to find out. But here's the surprising truth. The spare tire wasn't removed to save manufacturers money, though it does save them money. It was removed because the car itself fundamentally changed, and the space where the spare lived became one of the most contested pieces of real estate in modern vehicle design. Today, we're unpacking why the spare tire disappeared, what replaced it, and why that replacement has serious limitations, and what the shift reveals about the quiet trade-offs built into every new vehicle before it reaches the showroom. To understand this properly, you have to go back to the moment the spare tire appeared in the first place, because its origin tells you something important about why its disappearance is more significant than manufacturers tend to advertise. The earliest motor vehicles did not carry spares. Tires in the 1890s and early 1900s failed so frequently, and the roads they traveled were so rough that a driver setting out on any journey of meaningful distance expected to deal with multiple punctures and carried repair patches and inflation equipment rather than a complete replacement. The pneumatic tire technology of the era simply wasn't reliable enough to make carrying a single spare wheel practical. It would have been used before the end of the day. What changed was tire quality. As rubber compounds and manufacturing processes improved through the 1910s and 20s, punctures became less frequent. A single spare wheel, mounted on a full-size rim and inflated to the correct pressure, was enough to get a driver home from almost any ordinary incident. The spare became standard equipment on every production vehicle and stayed there, essentially unchallenged, for nearly a century. Think of the spare tire like a fire extinguisher in a building. You don't design a building around the expectation that it will burn, but you install extinguishers because when the rare event happens, the cost of not having one is catastrophically disproportionate to the cost of carrying it. For decades, the spare wheel was treated the same way. Small, predictable cost, significant occasional benefit, no serious argument for removing it. The argument arrived in 2 forms simultaneously, and it came from directions that had nothing to do with tires at all. The first was regulation. Through the 2000s and into the 2010s, fuel economy and carbon emission standards tightened progressively in every major market. In the United States, the corporate average fuel economy standards required manufacturers to meet fleet-wide consumption targets that became harder to reach with each revision. In Europe, carbon dioxide emission limits imposed direct financial penalties on manufacturers whose vehicles exceeded the threshold. Engineers working to close those gaps measured everything the vehicle carried and asked whether each component was earning its weight. A spare wheel assembly, including the tire, The rim, the jack, and the wheel brace typically adds between 15 and 25 kilograms to the total vehicle mass. Across the hundreds of thousands of fuel economy test cycles run to establish official consumption figures, that mass has a measurable effect on the result. Removing it nudges the published figure in a favorable direction, which reduces regulatory exposure and improves the marketing headline. The second pressure was spatial, and it arrived with far greater force as the industry shifted toward electrification. A battery pack for a hybrid or fully electric vehicle is heavy, chemically sensitive, and needs to be positioned low in the vehicle for stability. The floor of the rear load area, where the spare tire well had traditionally been located, is structurally well suited to housing battery modules. It's protected from frontal impact by the passenger compartment, it keeps the weight centered and low, and it is accessible for manufacturing. Redesigning that space to accommodate a battery, while also retaining a tire well, is possible, but adds cost and complexity. The tire well, which contributed nothing to the vehicle's ability to move, was the obvious candidate for removal. So if the space and weight arguments are real, what do drivers actually get in place of the tire they've lost? The answer, as is often the case in history, comes down to a substitution that works well in one specific scenario and fails in several others. Tire repair kits use an aerosol foam sealant that is injected through the valve stem and coats the inside of the tire, sealing small punctures in the central tread area from the inside. For a clean nail or screw penetration of under 4 millimeters in diameter in the middle of the tread, the kit works reasonably reliably. For a blowout caused by a curb strike, for a sidewall tear, for a puncture caused by a larger object, or for any tire damage on the shoulder or sidewall rather than the central tread, the foam is useless. It cannot bridge a structural tear. It cannot restore a compromised sidewall. And once a tire has been treated with sealant foam, it typically cannot be conventionally repaired, meaning a tire that might otherwise have been plugged and returned to service must instead be scrapped. The kit solves the most common type of roadside puncture and provides no answer to any of the others. Run-flat tires, which use reinforced sidewalls to remain drivable for limited distances after a pressure loss, address a wider range of incidents but cost significantly more to manufacture and replace, and produce a noticeably firmer ride that many drivers find uncomfortable over longer distances. What neither solution replaces is the simplicity and universality of a spare wheel. A spare can be fitted by anyone with basic mechanical competence in under 15 minutes, in any weather, at any time of day, without a phone signal, without a power source for a compressor, and without any dependency on whether the damage happens to fall within the narrow category the repair kit was designed to address. So the next time you buy or borrow a car and find yourself lifting the boot floor to check what's underneath, you'll know what that empty well represents. Not an oversight. Not a cost-cutting shortcut. Though it is also that. It's the physical record of two converging pressures, fuel economy regulation and battery packaging, meeting in the one space in the car that had no advocate when the compromises were being made. The spare tire was removed because it couldn't make the case for itself in a boardroom. It only makes the case for itself on a dark road in the rain, and by then it's too late to order one.